Hey guys, Mr. Backerberg here. In this video, we're going to look at the derivative of a sine function. So trig functions are important because many phenomena that we see and want information about are periodic. So things like heart rhythms and earthquakes and tides and even the weather. And continuous periodic functions can be expressed in terms of sines and cosines. So then the derivatives of sines and cosines also play a role in describing the periodic change. So the first thing that we're going to look at doing is proving what the derivative of a sine function is. So we've got the equation y equals the sine of x. So what we're going to be doing to find this derivative is the limit of the sine of x plus h minus the sine of x all over h, and we're going to do this limit as h is approaching 0. So this is the limit of the difference quotient using that sine function. Now, one thing that we're going to have to remember about trig identities is there's a sine sum formula that says if we have the sine of some u value plus some v value, we can turn that into the sine of u times the cosine of v plus the cosine of u times the sine of v. So if we apply that to this first piece of our limit where we've got the sine of x plus h, we can turn this into the sine of x times the cosine of h plus the cosine of x times the sine of h, all minus the sine of x. And this is all still over that h value. Now I'm going to strategically rearrange this. I notice that this front term has a sine of x in it, and I notice that this very back term has a sine of x in it. So I'm actually going to flip-flop these last two terms. So then my fraction is going to say the sine of x times the cosine of h minus the sine of x plus the cosine of x times the sine of h all over h. And then with these two terms that have the sine of x in them, I'm actually going to factor the sine of x out of there. So then this is going to be the sine of x times the cosine of h minus 1 plus the cosine of x times the sine of h all over h. And now what I'm going to do with this is I'm going to unadd those fractions. So when I split this up, each piece from the numerator is going to get its own copy of the denominator. So this is going to say the sine of x times the cosine of h minus 1 all over h plus the cosine of x times the sine of h all over h. Now, because we have multiplication happening in here, I'm actually going to separate that off of this fraction. So where we have the sine of x times this set of parentheses all over h, I'm going to rewrite it as the sine of x times the fraction cosine of h minus 1 all over h. And then I'm going to do the same thing on the back end with this cosine of x that's in the front. So I'm going to write that as the cosine of x times the sine of h over h. And then one thing that I want to remember is that we're doing the limit of this whole thing. So where we have this multiplication happening in here, we can do the limit of each one of those pieces individually. So this is really going to turn into the limit of the sine of x as h is approaching 0 times the limit of that fraction cosine of h minus 1 all over h as h is approaching 0 plus the limit of the cosine of x as h is approaching 0 times the limit of that second fraction sine of h all over h as h is approaching 0. Now I'm actually going to use my calculator to help me evaluate a couple of these limits in here, and I'm looking specifically at those fractions. There's no simplifying in here that's going to allow me to cancel out that h on the bottom, so it's not going to be safe for me to actually plug 0 in for this h. So I'm going to numerically look at those limits using my calculator. So in this first one, we're looking at the cosine of x minus 1 all being divided by x. And as we look at this graph, we're looking as x, or as h, is approaching 0. So as we approach 0 from each side, we can't actually plug in 0. That point doesn't exist. But as we approach from each side, that limit is approaching 0. So as we're looking at these limits in here, we can't plug 0 in for h because there is no h in here. So this is just going to stay as the sine of x times. We just numerically looked at this limit and said that was 0. Plus on the back end, again, we can't plug in an h value of 0 because we don't have any h's in here. So this is just the cosine of x times. Now I suppose we still need to do this limit, and we're going to do this one numerically on our calculator as well because we can't safely plug 0 in here, and there's no canceling that's going to allow us to get rid of that h on the bottom. So this one is going to be the sine of x divided by x, and we're using x in here instead of h. So as I graph this out, and as we approach 0 from each side, again, it's not safe to actually plug in 0, but as we approach 0 from each side, it looks like that limit is approaching 1. So this limit on the end is 1. Now in the front here, if I take the sine of x times 0, that's just 0. On the back, if I take the cosine of x times 1, I just get the cosine of x. So going through and doing all of that work, we just proved that the derivative with respect to x of a sine function is the cosine of x. So now that we know what the derivative of the sine of x is, now we can use it to help us do some differentiation. So we're going to find the derivative of the function y equals x squared times the sine of x. Now if we're going to differentiate this, we're going to have to use our product rule. The x squared is going to be our u, and the sine of x is going to be our v. So the product rule says that we're supposed to do u times the derivative of v plus v times the derivative of u. So if I leave u alone, that's x squared, times, if I do the derivative of v, well, we just proved that the derivative of the sine of x was the cosine of x, plus leave v alone, so the sine of x times differentiate the u, and that's going to be 2x. Now I'm going to rearrange this just slightly and bump this 2x to the front. So I'm going to write this as x squared times the cosine of x plus 2x times the sine of x. So we were able to differentiate that using our product rule after we knew what the derivative of sine was. That's going to be it for this video. Thanks for watching.